Okay, so today we're going over multiplying and adding radicals. Now, let's start with multiplying. Multiplying radicals. Let's start with that. Multiplying radicals. Now, what's important to know when you first start multiplying radicals is that to multiply two radicals together, the radicals' indexes must be the same. Now, if you don't know what a radical's index is, the index of a radical is actually just, let's say I have a square root of x. This 2 right here is going to be the index. So whatever number you have right here can be any number. That's the index of a radical. So to multiply two radicals together, their indexes must be the same. So these can both, if they're both 2, then you can multiply them together. But let's say there were 2 and 3, then these radicals could not be multiplied together. So just make sure you know that when you're multiplying two radicals together, their indexes or the number right here must be the same. Okay, now let's just start off basic. Let's say we're multiplying the square root of 3 times the square root of 4. The way we're going to solve a problem like this is actually quite simple. Their indexes are the same. They're both 2. So we know that we can multiply these radicals together. So to get our answer, all we have to do is multiply what's inside the radicals together in this case. So all we have to do is multiply 3 and 4 together. And all we'd get is the square root of 12. So we multiplied 3 and 4 together, and we'd get the square root of 12. So even if I added like a 4x right here, it would still be the same. Which you would just multiply them together, 3 times 4x, you get 12x. So when you have a problem like this, no matter what the index is, if they're both 3, then the problem would still be fine. You just put a 3 here. Whatever the index is, all you have to do a problem like this is multiply what's inside the radicals together. Okay, now let's move one step further, one step more advanced, still not too tricky. Let's say you had a problem like 2 times the square root of 5 times 3 times the square root of 10. Let's do that. Okay, so what we're doing is similar to what we just did in the last problem, but this time we have numbers in front of the radical. And the way we're going to solve a problem like this is we are going to multiply the numbers in front of the radicals together. So 2 times 3, that would get us a 6. And then we'll just do what we did in the last problem, which is basically just multiplying the numbers inside of the radical together. So 5 times 10, and make sure not to forget that square root sign, so that would be the square root of 50. Now, the square root of 50 can be simplified, and if you don't know how to simplify a radical, then I recommend you go check out the simplifying a radical video that I made quite a while ago. I might update it, but yeah, you should know how to simplify radicals before you move on to multiplying and adding them. So if you already know how to simplify a radical, great. We're just going to simplify this. So make our pyramid or tree, and then this breaks down to 5 and 5. And then we have a pair of 5s and then a 2 that's left out all by itself. So this square root of 50 can become 5 square root 2. Now, if we take out the square root 50 and put in its place 5 square root 2, then we're just multiplying the 6 and the 5 square root 2 together. And because 6 is not inside of a radical, we're just going to multiply it with 5, who's also outside of the radical. So that would just get us 30 square root 2. 30 square root 2 is going to be our final answer. So that's how we would do a problem like this. Now let's move to, let's say, the final step that we're going to do today. The final advancement, I don't know. Just the final problem, multiplication radical problem we're doing today. That's going to be, I'm adding variables. So let's say we had 45 x cubed y. Then we are multiplying that by 32 x y to the fifth. Okay. This is our problem. Now, adding variables, this might look a little bit overwhelming, but it's actually not too hard. We're going to do what we've been doing in the last two problems, which means we're going to multiply the things that can be multiplied together. So we'll multiply the numbers together, then multiply the x's together, then multiply the y's together. And let's make our answer. Let's say we have a square root. Now, we couldn't multiply 45 and 32 together. But if we did that, we'd have a really large number, and I can't really do that off the top of my head. So what's actually a really convenient shortcut is 45 times 32. We can just put that like 45 times 32 inside of the square root sign, inside of the radical, let's say. And we can just simplify them like this. So I'm simplifying the 45, and I'm simplifying the 32. That's a 2 and 2, and that's a triple 2. Right? Okay, so we simplified the 45 and the 32. And now let's just act like we're simplifying two different numbers. So 3 is a pair, 5 is left out. Let's see, we have 2 pair, and 1 left out. Okay, so now what we have in combined from both 45 and 32 is we have a 3 pair on the outside, we have a 2 pair, we have a 2 pair, and then we have a 2 on the inside. So all of this, 45 times 32, translated to this. It's simplified down to that. Now, if we multiplied 45 by 32 and we simplified that, we would have gotten the same thing. We would have gotten, let's see, this is 12 square root 2. So that's a really convenient shortcut. Instead of multiplying the 45 and the 32 together, all we have to do is put the 45 times the 32, put your two numbers in the square root sign, simplify them together, and then just combine the two different simplified radicals, multiply them together to get a final answer, let's say simplified form of that number. So we have 12 square root 2. The 45 times 32 has become the 12 square root 2. So let's put that in our answer. So we have 12, and then we have square root of 2. Now the x's. Let's multiply the x's together. That's going to get us x times x cubed is going to get us x to the 4th power. Now, if we simplify x like it's a radical, it's going to get us x times x times x times x, right? So it's going to get us two pairs of x's. So we can just act like this is a radical. Let's say we have 2 pairs of x's, and then put those 2 pairs of x's outside of our answer. So that's how we're going to deal with this. We're multiplying the x and the x together, and all we're doing is putting it outside, simplifying it like it was a radical. Now, let's say there was no y here, and let's say there was only one y in the entire equation, just this one y. If you had that situation, you wouldn't do any simplifying or anything. You just put it right into the radical and in your answer. But in this case, we do have a y times y to the 5th right? That's going to make a y to the 6. Y to the 6. And we're going to do what we did with the x. We're going to break that down. So that's y times y times y times y times y. Uh-oh, I'm squished here. I'm just going to put it down here. Okay, that gives us 3 y pairs. 3 y pairs. So, like we did with the x, we're going to put all of these 3 y pairs outside. So, let me just move this. So, we're going to put the 3 y pairs outside. So, times y times y times y, and then keep the square root 2 here. So, this we could say is our final answer. However, we can multiply all of this together. If we multiplied all of that together, that would get us 12x squared y cubed square root 2. This is going to be our final answer. Now, problems like this, I feel, are they aren't too difficult, but they're a little long, and it's kind of possible to make silly mistakes. So I think this needs some practice if you want to get better at this. So you could rewatch this part of the video, but to help you even further, I think I'll put like some practice problems like this of the harder variety in the description below. So you could just write those down on paper and practice them. Only if you feel like you need some extra practice in doing this. Okay, so that's multiplying radicals. Now let's move on to adding them. Now we're moving on to adding radicals. So adding radicals. Okay, so when we're adding radicals, what's important to know is that you can only add radicals that are like terms or that are exactly the same. So let's say we had a problem like square root of 3 plus the square root of 4. Now, we cannot add these together because they're different. And even if we simplified this square root of 4, 2 and 2, 2 and 2, 2 pairs. Yeah, I'm just showing the work, but it's obviously 2. Even if we simplified this down to 2, we still couldn't add these together because they're different. They aren't like terms. So what's important to know is that you cannot add radicals. Oh, wait, let me just erase this. You cannot add radicals that are not like terms. So we couldn't add something like this. But we can add something like, let's say we had the square root of 3 plus the square root of 3. We could add something like this. So these are the kinds of things that you're going to be adding together because they are like terms. Now, let's say I gave you a problem like 3 times the square root of 3 plus 4 times the square root of 3. Now, I know that the number in front of the radical, I know that this 3 and this 4, they're different. They aren't like terms. But the square root 3 and the square root 3 are both like terms. So we can, in fact, add these two things together. So it doesn't matter the numbers in front or what's in front of the radicals, could be variables, are not like terms. Only matters if the radicals are like terms or not. So we could add this. And the way we're going to do that is we are going to add the 3 and the 4 together. So add what's in front of the radical together first. So it's going to get us to 7. And we're actually going to keep, because they're like terms, we're going to keep the radical the same. So we're going to keep it as square root 3. So our answer in this case would be 7 square root 3. Okay, now let's move on to something a tiny bit harder. Let's say we have the cube root of 81 plus 10 times the cube root of 3. Say we had that. Okay, so now you might be saying, okay, these are not like terms. The square cube root of 81 and the cube root of 3 are not like terms. But if you are given a problem, and you notice that the radicals are not like terms, what you should try and do always first is simplify. Because if you notice, we can simplify this cube root of 81. That's going to get us 4 3's, and that will give us, let's see, 1 3, a trio, and then a 3 left out by itself. So the cube root of 81 can actually become 3 square root 3, or cube root 3, my bad. Cube root 3. And if we swap the cube root of 81 for 3 cube root 3, what you notice is we can actually do this problem now. We can do this problem. It's just like what we just did. So, like I said before, all we have to do is add what's in front of the radicals together. So 10 plus 3, that's 13. And then we keep the radical the same, so that's going to stay as 3 cube root 3. So what's important to get from that problem is that if you're stuck on something, you think that they can't be added together, try and simplify the radical. Okay, so final question. We have the square root of 18x cubed times y to the 4th power minus x times y squared times the square root of 50x. Now, our radicals, they aren't like terms, so obviously what we have to do, what I was explaining a bit earlier in this video, is that we have to simplify so that we can make our radicals like terms. So let's start with the square root of 18x cubed y to the 4th power. And let's just start with 18, right? So 18, we make our tree, so 9 and 2, then 3 and 3, right? And then we have a 3 pair. Then we have a 2 left out by itself. So I'm just going to put that 3 square root 2 right here. Now let's move on to the x cubed. Now, like we did earlier in this video in the multiplication, with x cubed, we're going to act like it's just a number, or that we're simplifying, a radical that we're simplifying. So we're going to factor it into x times x times x. Then as you can see, we have an x pair, and then we have an x that's by itself. So that x pair is going to go on the inside, and then, sorry, I meant the x pair is going to go on the outside, and the one that's left out by itself is going to go on the inside. So here, just to make it a bit more neat, let me rewrite that. 3x times the square root of 2x. Okay, now finally we have y to the 4th. Right? Y to the 4th. Okay, we're going to factor it like we did with the x. So y to the 4th becomes y times y times y times y, which is 2 y pairs, which means that there will be 2 y's on the outside. So that becomes y times y, or just y squared. So we've converted or simplified this into this. Now, they're still the same thing. They're just in different forms. Okay, so let me replace this with this. So let me erase all of this. And let's put it in 3xy squared is the square root of 2x. Okay, now let's move on to this part of our equation. Now, the x and the y squared, they're already on the outside. There's not much we can do with them. So let's just right away put them on the outside. X times y squared. Okay, but this 50, we can do something with it. Let's simplify it. So 25 and 2, 5 and 5. We have a 2 left out by itself and a 5 pair. So that 5 pair is going to go on the outside, and then that 2 is going to go on the inside. Now this x, it's by itself. There's not much we can do with it, like the x and y squared over here. So we're just going to keep that inside of the radical. Keep it as 2x. So we converted or simplified this into this. So now let's replace it. Let me erase this. And we can put in the 5xy squared times the square root of 2x. Now, as you can see, once we've simplified, we do have like terms, square root 2x and square root 2x. So we can subtract these. So 3xy squared minus 5xy squared is what? It's negative 2xy squared. And then like before, we aren't going to do anything with the square root 2x. We're just going to keep it like that. Square root 2x. So this is going to be our final answer. Now, like with the multiplication, this might take some practice to master. So I will put a couple of practice problems just to make sure that you're a little more familiar with adding, subtracting, and multiplying radicals. And yeah, thank you so much for watching. I'll see you in the next video.